Hi, everybody. All right, here is your all-encompassing review video for compound inequalities, because I know there were a few people absent for some of the parts, so I was like, oh, I better do this to help them out. So remember, today we're going through 4 different parts. We're going through how to write a compound inequality, how to solve them with the word and, how to solve them when they have the word or, and then also how to write them in interval notation. So I'm just going to kind of quickly go through some of the slides that we had in class, and then you can pause it, rewatch anything that you need help with. So here we go. All right. So part 1 is just about writing compound inequalities. As we talked about, they will either be joined with the word and or the word or. If you have an and compound inequality, notice that it's almost combined in the middle here. We talked about it as being like the overlap, etc. However, when you have an or inequality, notice that it's shooting off into both directions. So those are the 2 distinctions between an and or an or. To quickly generalize, our and compound inequalities can either be written as x is greater than 2 and x is less than 6. But more commonly, you'll see them written as a single inequality. 2 is less than x, which is less than 6. You can also notice that on your graph here, they have the overlap. And then also, this is not anything new, but when you have these less than signs, you would have open circles, whereas if you had less than or equal to, they would be closed circles. For our or inequalities, you're going to know it's an or inequality because it has the word right there for you. And when you graph that, it'll be going off into separate directions. So let's go ahead and translate some of these into an inequality and then practice graphing. So it says all real numbers that are greater than -2 and less than or equal to 3. So right away, we know that this is an and inequality, okay, which means that we can write it as a single combined compound inequality. So it says, okay, greater than -2, less than or equal to 3. Less than or equal to 3, we've got x. Here we are. Sometimes you can kind of, not like cheat the system, but start with your smallest number on your left side and then have your greatest number on the other side, and x should be in the middle, and just be cognizant of the signs. Because our -2 utilizes this less than sign here, that'll be an open circle. 3 will have a closed circle. And then we're going to go ahead and shade in the middle because x is in the middle of these 2 values. So there you go. All right, let's go ahead and look at another one. It says all real numbers that are less than 0 or greater than or equal to 4. Okay, well, it tells you the word or is right there. So you have to know that that's going to be an or compound inequality. So it says less than 0, or greater than or equal to 4. Notice that when you write out this compound inequality, you actually use the word or. And then we can go ahead and graph. So x is less than 0. Because it's just less than, it'll be an open circle, and we shade all real numbers less than 0. For our second part, when it says greater than or equal to 4, greater than or equal to, that's going to be a closed circle, and we're going to shade all of our real numbers that are greater than 4. Okay, last one. All real numbers that are less than or equal to 0 and greater than -5. It has the word and in there, so we know that that's an and compound inequality. So again, use my little hack. 0, okay, that's going to be your largest number technically. You've got -5, and we know x will be in the middle. It says less, oh gosh, this should be less than or equal to 0. Less than or equal to 0, and then just greater than -5. So we'll have our open circle here, closed circle here, and because it's and we have x in the middle, we shade in the middle. Now, the second part of our lesson is when we were solving compound inequalities that involved the word and. And remember, all you have to do is just separate it into 2, solve, and then recombine and graph. So if I was looking at this one here, first of all, you know right away that this is an and inequality because it's combined into one single one. So we can separate this into -3 is less than or equal to m minus 4. And then we can also write it where you've got m minus 4 is less than -1. So it's like we take that compound one and we break it into 2, and then we'll solve individually and then recombine. So if I'm solving for m here, the inverse of -4 is adding 4. So we will add 4 to both sides. And when you do that, you still have m right here. Keep our sign. -3 plus 4 is just 1. On this side, and I'm not sure why I switched colors, we keep our m, and then the inverse of subtracting 4 is adding 4 to both sides, and then we're left with m is less than 3. Now we just need to combine it into a single inequality. So I've got 1 is less than or equal to m, and then m is less than 3. That's it. You did it. And then you just need to make sure that you're kind of watching your signs here, or your circles. So because this is less than or equal to, it'll be a closed circle. This is just less than, it'll be open, and then you shade in the middle. All right, now moving on to solving compound inequalities that use the word or. These ones are actually simpler because it's almost like they're just two separate inequalities that you're going to go ahead and solve. So we'll do this one first. That color is awful. Okay, so we just go through our standard solving process here. And then divide by 3, and we get that x is less than -3. So that's our first solution here. Remember, it's going to be joined by the word or, and we'll do that at the end. For our second one, all we have to do is just solve it again. Sorry for all the loud noises. Okay, so we'll subtract 5 from both sides. So we've got -4x is less than -4. Divide both sides by -4, and hopefully there's something going off in your head. When you divide an inequality by a negative number, you have to flip your sign. So when you do that, it turns into x is greater than 1. So your final answer, if we write it nicely, is x is less than -3 or x is greater than 1. Now, when we graph this, we're still going to graph them almost separately. So x is less than -3, all the numbers less than -3, or x is greater than 1, open circle here, it's just greater than, and then we highlight and shade all of the numbers greater than 1. You also have a clue that you did it correctly because when we have an or inequality, your graph should have it shooting off into two separate directions. Okay, last thing, interval notation. If you look in your book, it has all of these like special little things to show you different examples with interval notation. Sometimes it makes it kind of complicated. Here's pretty much the lowdown. When you have a less than or a greater than sign, we are going to use parentheses. When you have less than or equal to or greater than or equal to, we will be using brackets. Cheat sheet part 2, when you have an and inequality, it's just going to be one little single interval notation. So it could look like this, something like that. But when you have an or inequality, you're almost going to have two different sets here. And you're always going to talk about negative infinity and positive infinity. So here's an example. So notice, because remember, when you graph those or inequalities, they're going off into those separate directions forever. Okay, that's why we have to cover negative infinity and positive infinity. And you always use a parentheses with those. So let's go ahead and take a look at a few. Oh, and then here's my generalization slide. I should have just showed this one. When you have your and compound inequality, you're going to have a single interval here. But when you have your or compound inequality, you know that you're going to need that negative infinity and that positive infinity. And please don't judge the way that I drew it. You know I'm not a good artist. Okay, so if I showed you this interval, first of all, you can actually write this out as an inequality. We know that this is going to be and because it's just one single interval. So we've got -4. This bracket tells me that it's going to be less than or equal to x. I see a parentheses, so it'll just be less than 6. And then close circle at -4. Let's pretend there's a 6 that'll have an open circle. And because it's and x is in the middle, we shade right in the middle. If you're like, how do we know if this is and or? Well, my friends, it literally tells you or right here. So it says you've got -infinity to 2. Okay, well, first of all, 2 has a parentheses, not a bracket, so it's going to be an open circle. And then we highlight everything going down to -infinity. Or 4 to infinity. Well, the 4 has a bracket, which means it's going to be a closed circle, and it'll shoot off into infinity, covering infinitely many real numbers. Okay, I think this is the last one. So again, let's go ahead and start by writing this as a compound inequality. So because this is single, we can write it as like a joined inequality here. So we'll start with -2. I see a parentheses, which means that it's just going to be a less than sign. Put x in the middle. And then the bracket tells me it'll be less than or equal to 5. And then we just take what we know about graphing. So less than, open circle, less than or equal to, closed circle, and we just shade right in the middle. So just to sum up everything that we covered in our compound inequalities lesson, because it was quite a lot. When we have compound inequalities, they're joined by the word and, or they're joined by the word or. Our and inequalities can be written as a single combined one with your variable in the middle. We also know that when we graph it, it's almost like there's like an overlap. There's like space that's in the middle there. When we have an or inequality, it's going to be shooting off into separate directions. And you'll notice that there's like empty space. You can't even see that. There's like empty space here, which is almost kind of like where your variable, no, never mind, that's for and. Ignore me. This is just like an empty space that's here because those numbers are not covered by your compound inequality. When we're solving compound inequalities with the word and, we can separate it almost into two separate ones, solve, and then rejoin into a compound. And then you also know that when you graph it, it should look like an and inequality. When you solve an inequality with the word or, it's already separated. You just solve them separately, and then you just write it into one concise little statement using the word or. And when you graph it, it should be shooting off into both directions. Lastly, when we're talking about interval notation, we use parentheses when there's a less than or a greater than symbol. We use brackets when there's a less than or equal to or greater than or equal to, because it shows that that number is included in your interval. And then whenever you have your or inequality, we know that we're going to have to use the infinity and the negative infinity. So here's an example of an and or a compound inequality here, where you see it's just a single interval notation and it's graphed with like overlap in the middle. Whereas when you have your or inequality, you see the two different parts. You have negative infinity, positive infinity, and it's shooting off in two separate directions. Okay, I think that's it. If you have any questions, you just let me know. Your Jamboard is due by 11:59 tonight, and then I'll see you tomorrow morning. All right, thanks, 8th graders. You have a wonderful day. See ya.